All right. Hello, my name is CJ Sturgess. I'm a partner solutions architect at Amazon Web Services. And today we're going to talk a little bit about beyond cloud native and risk evolution in the age of agentic workloads. So, as far as agenda goes for today, our discussion is going to talk about the evolution of cloud architecture, what changes with AI, layered defense, which is really our only defense in depth, and future considerations, which is adoption and marketplace dynamics. To open, there's this quote that I came across recently in an article I read that I really like. It says organizations deploy AI systems that spawn subagents, rewrite their own code, and finish execution of actions before security teams finish their morning coffee. I think this pretty eloquently summarizes the state of AI adoption and security adaptation today, wherein AI tooling and services are leaps and bounds accelerating faster than most of our security practices. On that metric specifically, actually, we talk about AI adoption. We've learned that about 88% of organizations have adopted AI tools and services in one way or another within their organizations today. However, about 35% of those same organizations cite that cloud security is their biggest lack of expertise within their organization, making this a really interesting and perplexing challenge to kind of match the pace of adoption within their own enterprises. So let's look a little bit at the evolution of cloud architecture. So originally, when we brought our workloads to the cloud, we talked about the initial cloud native architectures, which were host-based architectures that had defined parameters. So generally, security focused on network boundaries, static credentials, and centralized identity management. And applications consumed cloud services through predictable and human-defined patterns. As we moved a little bit further and got more advanced with our workloads in the cloud, we moved into serverless and containerization. Here, we had distributed ephemeral workloads that operated across orchestrated environments. Security generally shifted to service meshes, including dynamic credentials and policy as code, and developers became active participants in security decisions, which generally blurred the lines between traditional operational boundaries. And now, as we move forward into the future, we're talking about the new upbringing of AI native and agentic workloads. These are large language model integrated applications that have autonomous decision-making capabilities. So these systems can dynamically access services, generate code, and in some cases also spawn sub-processes. And security has to account for these new machine speed actions and non-deterministic behavior patterns. So how do we think about AI security strategically? Well, the first point is that ubiquity is inevitable, so we should plan for it now. AI is not going to remain isolated in pilot projects, but rather it's going to touch every business process. So think customer service, supply chain optimization, financial analysis, and HR systems. Security is not just going to be, and it can't just be, an afterthought when AI is already integrated into our critical business functions. The next thing that we need to consider is that the traditional perimeter security model doesn't work with AI. AI systems cross traditional security boundaries. For example, they connect databases, APIs, external services, including other third-party platforms. So a single AI application might touch your CRM, ERP, data warehouse, and again, third-party APIs. And that's just in one application. So defense in depth means that we need to secure every connection point and not just the model itself. The everywhere principle of the statement itself is basically that security controls must match AI's reach. If your AI can access sensitive data, customer data, financial records, for example, your security has to cover all of those touch points. We can't just secure AI in isolation. The entire ecosystem it operates within must be secured. And the third point I want to make is that AI security can be a catalyst for broader security improvements. So securing AI forces us to implement modern security practices, such as zero trust, least privilege, and continuous monitoring. And these improvements would benefit the entire infrastructure and not just the AI workloads we're running on them. So these security requirements often generally reveal gaps that are pre-existing within our current security posture. This represents a strategic security mindset shift from securing AI to securing with AI in mind. So we want to design security architectures that assumes AI will be integrated everywhere, and we want to build frameworks that can adapt as our capabilities expand. So we want to use AI security requirements to drive enterprise-wide security modernization. And the bottom line here is that AI security isn't a separate discipline. It's enterprise security that's been evolved for the AI era. There are two completely different security disciplines that often get confused. The idea that security protects against external threats and malicious actors outside of the AI model, whereas responsible AI addresses ethical concerns and societal impact from within the model itself. The security focus is on protecting our AI systems from becoming compromised and preventing hackers from stealing our models or data, for example, stopping unauthorized access to endpoints and data or other services, blocking prompt injection attacks, and other traditional cybersecurity measures that are applied to our AI workloads. On the other side, responsible AI's focus is on ensuring that our AI behaves ethically and reasonably. So preventing bias in hiring and lending decisions, for example, avoiding generation of harmful or misleading content, and ensuring fairness across different demographic groups is just one key example of responsible AI practices. These can both be considered security practices, but how they operate is critical. Security is outside the model, whereas responsible AI is within the model. This presentation we're talking about today is 100% focused on the security side of this model. We're talking about protecting AI infrastructure and not policing its outputs. We want to think about firewalls and encryption, not bias detection and content filtering, for example. So traditional security teams would likely recognize most of these concepts. Both are important, but they require different expertises and different approaches as well. Security, though, is foundational, and that's what we want to get right first. So let's look at security outside the model. This slide really does define our security philosophy, which is don't try to make the AI model secure the infrastructure and everything around it. The model itself is a black box that has unpredictable behavior usually. So we want to focus on controlling what goes in and out and what the model can access. So from deterministic controls perspective, we want to use predictable security mechanisms. Traditional security tools like firewalls, access controls, and encryption generally work the same way every time. They're deterministic in behavior. Unlike AI models, security controls produce consistent and reliable results. And so, for example, an IAM policy operates with the same level of permission enforcement, regardless of the request content. You are who you are, and we can authorize that every time, for example. Security before data reaches the model. In this, we want to implement controls at the perimeter. So filtering and validating inputs before they get to the AI model, for example. We want to authenticate users and authorize access before they process requests, sanitize prompts to remove potential injection attack positioning, and think of it as a security checkpoint before AI processing begins. A quick example of this is, for example, take an AI application that's connected to one of your knowledge bases. Should every user who interacts with the AI tool or model also have the same level of access to the knowledge base? Generally, we might want to filter out potential results or limit portions of the knowledge base to specific user roles, and that needs to extend to the model itself as well. And on the far right-hand side of the slide, we have defense in depth security architectures. So we don't want to rely on a single security measure, but rather use multiple overlapping protections. So for example, network security, identity management, data encryption, and application controls. The same approach is used for traditional applications, but now we're extending it to AI workloads as well, with a few extra caveats. Really, the insight here is that this approach leverages existing security expertise. We want to apply proven security principles to this new technology. Models can be unpredictable, but security controls shouldn't be. We want to let AI be creative and autonomous within secure boundaries. Let us define those boundaries using security controls that are reliable and tested. At AWS, we call this defense in depth security. So every layer needs to be taken into consideration to build a strong foundation around security, especially for AI and agentic AI workloads. So you can kind of think of it like building a castle. You don't want to just put up walls and call it secure. You also need other layers of protection, moats, guards, gates, for example. And each of those serves a distinct purpose. So if we look at the base layer, we see things like policies, procedures, and awareness that help us make sure that we have the right foundation in order to define any security or other functional capability that we want to build on top of that layer. It's really important for generative AI use cases in particular to know exactly what is required from both a security perspective and from a safety perspective as well, for both internal use cases, customer-facing use cases, any use cases that involve sensitive data, and any more that will come into play down the line. As we move a little bit up the stack, and we won't go through all of this, but as we move up the stack a little bit, we can talk about identity and access management. What users are authorized to access the AI workloads. If you have different roles for different users, like I mentioned with the knowledge-based example, does that change what they're allowed to access? Do we need to pass user identity to different parts of the application within an agentic architecture? These are some of the considerations we need to keep in mind when we talk about identity and access management. And then further, we continue to build up data protection. How are we building a secure foundation for the workloads to run on? The secure infrastructure, making sure we have the right infrastructure protection, for example. Once we do these things as a baseline, we can finally get into how the application and data layers play together, where things like guardrails, sensitive data disclosure, hallucinations, and other agentic-specific threats might come into play, and how we might need to protect those. This is important to not just think about the model itself with security, but also the overall architecture and the pattern that we need to provide the security foundation for defense in depth for our entire environment. Again, this is both includes AI workloads that we might be bringing into our environments, but also helps us protect our existing and overarching environments as well. So we can dive into each of these to talk about them in much more detail. But one that I really want to pick on today is threat detection and incident response. So let's take a look at an example application that has been AI enabled. You'll notice that architecture for this might look relatively familiar, and that's because generally most of these AI application architectures are still familiar. There's just new key points that we've included through either agentic enablement and integration or new third-party accesses, for example, that our applications may not have had before. So AI systems require specialized monitoring because they behave differently than traditional applications. Usually they have non-deterministic behavior, which makes it harder to define normal versus suspicious activity, for example. And there's other AI-specific indicators that we might want to look for that traditional security tools might miss. So for one, we want to monitor AI-specific anomalies and unusual patterns in usage. So for example, this might be accessing tools that they normally don't use and tracking agent decision deviations. Why isn't AI making a choice outside of our expected parameters, for example? AWS offers services to help you with this, such as Amazon Guard Duty and CloudWatch, which can be configured to monitor those specific anomalies. We also want to capture and analyze prompts, completions, and agent reasoning claims. So regularly right now, traditional logs might show API calls, but miss why did the AI make this decision, for example. We want to capture prompts, completions, and agent reasoning to understand why AI made the decision it did. Again, AWS services can help you with this, such as Agent Core Observability and CloudTrail. And this is generally essential for incident investigation and really understanding AI behavior in our environments. Next point I want to make is that we need to track which human users are behind actions. So AI systems can blur accountability because they usually operate on behalf of the user, for example. So we need to be able to trace those actions back to the human who initiated them. We want to monitor which data sources AI agents have access to and correlate that with user permissions. Again, going back to the knowledge base example. We want to use CloudWatch and CloudTrail with identity propagation to maintain audit trails. Again, to pick on a couple AWS services that can help you with this. And this is critical for our compliance and incident response. And finally, the last point I want to make on this slide is that we should also implement zero trust verification for every AI system interaction. AI systems can be manipulated to provide unauthorized access. We've seen this across the internet already in different use cases and case studies. We want to verify every system interaction and don't just trust based on previous behavior. Again, AWS services such as verified access and verified permissions can assist you with this, but it's really important for us to have this level of insight so we can see how our autonomous AI agents are changing behavior dynamically. The insight here is that AI monitoring requires both traditional security monitoring as well as AI-specific observability. So again, API logs and audit trails, but also add the additional AI and API context to those logs as well. Not just what decisions are being made, but why are those decisions being made, so we can help prevent against them in the future. We want to focus on maintaining accountability and traceability in these autonomous systems. To put that together, there's really three key areas we want to consider. And it's that AI security risk is determined by these three factors: untrusted data, external access, and sensitive data. Each factor alone presents a manageable risk, but together, their challenge is really in the intersection. Untrusted data, for example, includes any externally authored content that might contain prompt injections, something that might cause our model to go off the rails. User inputs, third-party APIs, web scraping results, uploaded documents, these are all key examples of untrusted data. We don't want to assume that external data sources are safe or free from malicious instructions. Sensitive data encompasses private user information, company data, and confidential business information as well. Customer records are a key example of this. Financial data, proprietary algorithms, internal communications, anything we may not want to become publicly available. AI systems often need to access this sensitive data to provide valuable business insights, but it's key that we're protecting that data as well as the infrastructure around it as well. The intersection of all three of these, as I mentioned, creates higher risk exposure. So compromised AI with sensitive data access and external communication capabilities, for example. That's not great. Deterministic security controls, though, can help us mitigate the risk of this type of AI behavior, and regardless really of any other type of AI behavior. Traditional security principles include access controls, data classification, and network segmentation, and we can extend that to our AI infrastructure and models to help us operate outside the model using predictable and tested applications and mechanisms. A good risk assessment framework will help you determine appropriate security measures for every different AI use case you might employ. Lower risk scenarios might require more basic security controls, whereas higher risk intersections need more comprehensive protection. Security investment should match the risk profile of your specific AI implementation. From a partner perspective, I mentioned a few of the AWS services that can help you as you build out these architectures, but in already running environments, for example, it might be important to bring in a partner to help you provide this level of security and observability that you might need in your infrastructure. So again, from a perspective, AWS works with a large number of our partners in both building agentic tools and resources, including for securing agentic tools. We recently launched the AI agent and agentic marketplace, which currently has over 1,000 different partner solutions in 3 key areas, including agentic AI and AI security. We also have a specific category that includes security competency focused on AI security, which now highlights partners that have been vetted by AWS and also meet a specific bar in terms of AI security posture management, threat detection and response, and AI data security, for example. One of these key partners is Qualys. They offer unique security solutions that can help protect your AI workloads and really your entire environments on AWS. Total Cloud is a complete security solution that seamlessly integrates into your AWS environment, including across both regions and multiple accounts if you have a multi-account setup, and can provide much of the application detection and response strategies and capabilities that we've discussed so far to help you provide a secure foundation for your AI workloads. This solution today is also available on the AI marketplace, or on the AWS AI marketplace. Speaking of marketplaces, there is an interesting effect that I'd like to talk to, and it's the marketplace acceleration effect. Something that we're starting to see is that organizations are deploying more and more applications. You largely think to this marketplace acceleration effect. Streamlined procurement helps organizations adopt more applications and faster. And specifically, one of the numbers that I've seen on this is that 38% today deploy somewhere between 1 and 5 AI-enabled tools or services, 42% of which currently adopt somewhere between 6 and 10, and more than 10 different tools and services are being deployed by 20% of organizations today. So what we're seeing is that new niche or maybe very problems are being solved by AI tools that are constantly emerging. And so organizations are adopting those faster than ever. So as we move into the future, we can expect that organizations will likely adopt several more times of solutions and applications than they currently have today, thanks to these new AI capabilities and features that are solving potentially very difficult and very unique problems to their industry or to their enterprises. So rapid development into new partners are quickly bringing capabilities to market. And what becomes really critical is as we adopt all of these new tools and services, we really need to keep a secure foundation to ensure that we're protecting our evolving landscape as we move forward. So to wrap up, there's 5 key points I want to make here. And it's that security approaches really need to evolve as rapidly as the technology is. As AI continues to evolve and become more and more sophisticated, so do the potential threats and attack surfaces that they offer. Security needs to be able to keep up with that pace of rapid development. AI native workloads also require rethinking traditional security approaches. Most of our traditional security approaches today can be extended to AI and agentic workloads, but require reshaping and rethinking to ensure that we're protecting the next generation of workloads. Additional threats come into play with AI agents that perform automated tasks. Kind of goes with the previous point here, but the idea is that we currently think of security in kind of a traditional model where we're deploying perimeter-based, or now we're getting into application detection and response type models. And we also think about the users that are initiating these application tasks and different capabilities. These are same things that we need to consider with AI workloads as well, but we also need to consider the AI agent as a persona in this security model. Customers should implement security holistically throughout the AI stack and integrated workloads. Again, we need to protect the entire infrastructure, and we want to build a secure foundation around our AI models and applications, and not just protecting the model itself, which again is effectively a black box. And lastly, partners can help you offer solutions to help secure your AI and agentic AI workloads. So to help augment your own security and technical expertise, lean on partners to help you provide the solutions that you need to evolve your business and your processes. To start today, 5 ways we can do this. 1, assess your AI risk profile. You can use that 3-circle risk model I presented earlier to evaluate your AI implementations, identifying where you have untrusted data, sensitive data, and external access capabilities, for example. Start with your lower risk use cases, so 1 or 2 circles at a time, before moving to high risk scenarios, and document your current AI inventory and classify this by risk level. This is really key. Moving forward, we can implement foundational security controls. So again, we can lean on AWS services such as IAM and Identity to help you provide least privilege access to all of your workloads, but also set up encryption at rest and transit. We want to configure network segmentation, provide secure access and network boundaries, and establish basic monitoring with, again, AWS services such as CloudTrail or CloudWatch, or with a partner solution. Deploy AI-specific security measures, again, including potential AWS services such as Amazon Bedrock Guardrails, which can help you offer content filtering and PII detection. Implement input sanitization and output validation controls, set up rate limiting and distributed DOS protection, and enable prompt injection detection and response mechanisms as well. These are AI-specific security measures. Establish governance and compliance. Create AI security policies and procedures that make sense for your level of risk tolerance and your organization in general. Implement the AWS Generative AI Best Practices Framework for auditing, for example. Set up approval workflows for high-risk AI decisions, and use human-in-the-loop controls, and that's key. Document incident response procedures specific to AI security response. We want to keep a robust compliance and audit trail. And finally, as you move forward, continue to monitor and iterate. Deploy comprehensive logging, set up anomaly detection, establish regular security assessments and penetration testing as well for your AI systems, and create feedback loops that continuously improve and evaluate your controls based on threats, usage patterns, especially as your use cases evolve. Thank you so much for your time today. It's been a pleasure to talk to you a little bit more about evolving security, risk infrastructure, and kind of foundations for agentic AI native workloads.